Our learning objective today is we're still solving inequalities, and our inequalities still have one variable in them. But now, as you discovered when you're SQ3Ring, there's going to be variable terms on both sides. Did you discover that solving inequalities that have variable terms on both sides is really just like solving equations, right? But what's the only difference? You have to make sure that you pay attention to, you can follow all the same steps, all the same thought processes, except you have to add one thought process in that you already know, that when you're solving inequalities, Trevor?
Symbol.
The symbol. And what about the symbol?
Pay attention if it's negative or
If you do what? In the process of solving, if you multiply or divide by a negative number, you have to make sure you reverse the symbol, right? So everything else still stays the same. You still have the same thought processes. So let's put at the top of this page that we're just doing lesson 2.5 practice. And the very first problem we're going to do, I'm actually going to have us do it two different ways because I'm seeing some kind of, funky things sometimes when I'm correcting your assessments. Okay, so number one, we're going to write this one down actually twice. 7 plus 4x is greater than or equal to 3x. So we're just going to solve it two different ways, and hopefully in the end we'll have the same result, same answer. When there are variable terms on both sides, everybody gets to choose what do you want to do first. You get to make your own choice on that. And in this problem, there are actually 3 different ways you could attack it. What's one of them? Subtract 4x. You can subtract 4x from both sides. Let's make that the one we do over here. Let's subtract 4x from both sides. And when these take care of each other, but they really become what? What does that really become? Plus 4x minus 4x. It really becomes 0. So we really have 7 plus 0, which is just 7. So we don't write 7 plus 0, do we? 3x take away 4x. Negative 1x. Okay, then we are going to do what next? Divide by negative 1. Okay. And 7 divided by negative 1? Do I need to switch the symbol?
Yes.
Yep, we divided by a negative, and we have x left alone on the other side now, right? Okay. So, what's another way we could have gone about solving this? Subtract 7. Okay, we could have subtracted 7, but there's not another constant on the other side really to subtract it from at the moment, so, with that, we can do that. But what I really want to do, and you can do that, by all means, that's the third way. But the other way we have is we can get, maybe you're the kind of person like, I actually like the variable term on the left side. Always. Whether it's an equation, an inequality, no matter what it is, for some reason I just like it on the left side. So I say, I'm going to get those x's off the right side so that they're over on the left side instead. So I have 7 plus what? 1x, which is just x, right? Okay. Is greater than or equal to 0. And the reason I wanted to show this one is because here's what I will see on papers. Sometimes students are like, well, you got to have something there, so maybe I'll just put an x there. But if you really have 3x and you take them away, do you really have any x's left? No. You don't have anything left, do you? In reality, what happens is this becomes a 0 just like it did in that other one, but there's nothing to add that 0 to, so we have to bring that 0 down. I will see some of the strangest things happen when everything eliminates on one side. I'll see, well, I got to put something there, but they don't think 0 is a legitimate thing to put there. It is. Okay, now we'll finish solving this one. What will we do? Subtract 7. And we will have x alone and is greater than or equal to negative 7. Is that the same thing really as this? Yeah, if I flip this over, would I have x is greater than or equal to 7? Yeah. So they're both going to get us to the right answer, but it's just which way do you prefer to do it. So you get to decide. Okay, go ahead and get it graphed. Seeing all kinds of funny things on the number line also. Let's make sure we understand that, you know, when we're sitting in here especially, we have a number line to stare at. Which direction should we shade this? To the right? Okay. Because the first one really says what? When we solved it this way, what does this say? -7 has to be what? Less than or equal to the shaded region. Is -7 less than that shaded region? Yeah. And the equal to part is our shaded in, right? And then this way says the shaded region, X, the shaded region has to be greater than -7. Are these numbers greater than -7? So we have to make sure that we can also display the graph properly, and I'm not necessarily seeing that all the time either. So, got that one? Any questions? Okay, I'm going to put one down now. You decide how you're going to solve this one. It's all yours, okay? This one's going to have actually 4 different ways you could start it after you get it simplified. So first we need to simplify this one, then we can go to work solving it. When you're done, you can look up and see if you did it my way. Because then I want you to verify if I did it right or not. Anybody do it my way? Sophia, you did? Okay. Are we in agreement? Okay. What the rest of you, what did you do first? What was your first move then, Cameron? You did that way too? Okay. What did you do, Mitchell?
I simplified it first like you did, but then I added 10 on both sides.
Okay, so you took care of the constant first. You wanted to move the constant first. Okay. Can we do that? Yeah. Absolutely we can. Yeah. Okay. Who did something different? Yeah, Alexis?
After I simplified it, I added 4x to both sides.
Okay, so add 4x to both sides instead. Can we do that? Yeah. There's still one more move we could have done. What would that be? What would be that last choice? So we've talked about what I did and some others did, subtract 5x. We talked about you could add 10 instead, or you could add 4x instead. Trevor? You could subtract the 8. So in reality, you know, there's 4 different ways to go about it, but we all better end up with x is greater than or equal to 2, right? When you add 4x to both sides instead, does your inequality turn out like this? That way instead? Yeah. So, is that the same as this? Yeah, absolutely it is. So we have it. Which way should we shade?
To the right.
To the right. We need is greater than again, don't we? Or 2 has to be less than all the shaded region. Okay, so when we are solving these, we don't have to have the same exact process, but we need to have something that actually is legitimate, that actually can be done. So any questions? Okay, let's do number 3 then. We have another one that you first need to simplify before you start solving it. a caution, we don't simplify it correctly, we're definitely gonna set ourselves up for not getting the right solution. So if you wanna check with a neighbor to see if they agree with your simplifying. Okay, will you guys check me out? Did I simplify mine correctly? Is yours the same? Yeah, okay. Why is it a +3 at the end? We really have a -3 here, right? And this is really a -1. So a negative times a negative is a positive. Okay, go ahead, you have, how many different starts could you make to this one? Oh, 4. There's 4 pieces, there's 4 different places you could start. At this point, I'm going to say to myself, and I'm going to write it down, the variable eliminated, you don't have to write this in your homework, but I would like you to write it in our practice. The variable eliminated, in other words, or use whatever word from the source that you want, is gone. It's no longer there. On both sides, when you add 3x, those x's cancel each other out. So there's only the 6 on the left side, there's only the 3 on the right side, and the statement is, so once the variable eliminates, now you got to say to yourself, what about that statement? Is it true or is it false? It is false. 6 is not less than 3, so we say the statement is false. The variable eliminated and the statement is false. That is not true. 6 is not less than 3. So what's that mean the solution is then? No solution. We have to state that there is no solution to this one. And what leads us to believe that is the fact that the variable eliminated and the result was a false statement. So basically it's saying no matter what you try with the number line, it does not matter what number you try. There is not a shaded region anywhere. There's nothing you can put into that original inequality statement that we solved and it would make it true, no matter what you try. Okay? Questions? Okay, try another one here for me, then. We're on the home stretch here. We got 2 to go. Okay. 4 4 times the difference of x and 1 is less than or equal to 4x. How many different ways are there to start this one? How many different ways could we start this one? Really only 2. Because one of those would be doing the same thing no matter what. So I just want us to see that no matter which of those 2 ways we do it, oops, kind of got out of my page here. Okay, so 4x is less than or equal to 4x plus 4. So did I really get anywhere there? No, but that happens. Sometimes you just do it and you're like, okay, I didn't really get anywhere. And sometimes you just keep doing things and you're like, kind of feel like you're on a merry-go-round, right? You just keep going round and round and not get anywhere. And then you end up with, finally this way when I do it, I end up with that statement. Does that mean can I not end up with that? Did I do anything wrong here? Look at both of my ways, and did I do anything wrong in either of them? These numbers are just different, aren't they? So can we end up with different resulting statements? Absolutely. It depends on which first choice we make. What do we do first? We may end up with a different result, but we better end up with something that actually gets us to that. But is this, so again, here's what we're going to say, the variable eliminated. So in our practice notes here, we're going to put that the variable eliminated and the statement, we're going to evaluate, is it a true statement or is it a false statement? Both of them? No matter which way I do it? Yeah, -4 is less than 0. 0 is less than 4, so no matter what, I end up with a statement that is true. So what's that mean? Our solution is all real numbers. It would not matter which part of the number line you chose. It would make that inequality true. Now we don't graph these because on the last one we would have to show an empty number line. We have no shading at all for no solution. For this one we would just show a number line. We pick, okay, what part of the number line do we want to show? We'd have to, randomly pick it and then we just shade. Well, so we're just not going to do that. We're going to write out no solution or all real numbers. Or we can use those symbols that we learned earlier when we were solving equations, right? What's the symbol for no solution? Circle with a slash through it, right? That means empty set. Okay. What's the math symbol for all real numbers? Yeah, the capital R with a double bar on its side. Yeah, it's got a double wall over there. Okay. Okay, let's go on to one more, and you're going to have to write out a statement here for this one. So number 5. 4 more than twice a number. 4 more than twice a number is greater than 2/3 of the number. No matter when we set up our own equation, set up our own inequality, we always have to pick a variable and we have to describe it. So what's the unknown? What's the variable going to represent in this situation? And what variable do you want to pick? Zach?
The number that is greater than 2/3.
Okay. Well, it's also the number that gets doubled, and so can we just call it the number? Can we just say, so what do you want it to be, Zach? Which variable? You want x? Okay, so x is really the number. There's a couple of different things that happen to the number in the problem. It's got this twice thing going on with it, and it's got this 2/3 thing going on with it, but regardless, it's just the same number, so it is the number. Okay, go ahead and write an inequality statement that you think represents 4 more than twice a number is greater than 2/3 of that the number. Sophia, are you willing to share with us yours? Okay, what is it?
I did 4 plus x squared.
X squared, so like this. Okay,
Is greater than
so like the symbol is greater than, okay?
2/3 x.
Okay, so let's go through this and see where these parts came from. So what's the 4 plus from? 4 more than, yeah. Because the word is not here, if it said is more than, that would mean we'd have to use the is greater than symbol, but this doesn't have the word is with it, so it means addition. So this is the more than part, 4 more than, in addition, order does not matter. And then the x squared, where does that come from? Twice a number, okay? Will that work no matter what x is? When's the only time it would work to do x squared? If it's twice a number, huh? When the number is 2. Because when the number is 2, you're taking it times itself, 2 squared, and you're actually multiplying it by 2. But does that work for the others? How about number 3? If we squared 3, would that be the same as twice 3? What's 3 squared? 9. And what's twice 3? 6. So would it work? No. So it only works if it only works for one number. That's not gonna work in this situation. So how could we change that up? What would we change that to, Landon?
2x.
2x. Okay, so twice the number. So you have to double it, no matter what the number is. Would this do it? Okay, and then is greater than. Well, that comes from these words right here because the is with it. So we know. You know what? That means it's an inequality symbol. 2/3 of the number means we need to multiply, doesn't it? So now I think we have it. Okay, now, there's lots of ways we could go about solving this. Lots. But I always like to get rid of fractions. And we talked about that back when we were doing equations. Said, how could we make this friendlier? Anybody have any thoughts as to what we could do to make this friendlier? Cameron, what do you think? I get friendlier when you feed me. Maybe we can feed it. No? Okay. Suggestion, anyone? What can we do to make this friendlier? I want to get rid of that fraction. I want to get rid of, just look at this. I want to get rid of that denominator. Multiply everything by 3. Let's take every piece of this inequality. Remember, if we do it to 1, we have to do it to the whole, every piece of it. So let's take every piece times 3. So we're taking the 4 times the 3. We have to take the 2x times the 3. We take the 2/3 x times the 3. So every one of these is getting multiplied by a 3. Every piece. And then we can put this 3 over 1, can't we? Yeah? And then now what happens is we got a 3 up, we got a 3 down, we're multiplying, we can do that. And now it makes it a whole lot friendlier. Because if you want to start subtracting 2/3 x or subtracting 2x or, then you get fractions to deal with for a while throughout the problem, and then you're like, oh, this is getting uglier, and I don't want to have to do it without my calculator, so now I'll go ahead and solve it after we've renamed it. What's your solution? What do you get? Oh, that's not a solution. I gotta hear the whole inequality. X is greater than -3, okay? Do we agree? The way I did it, I wanted my variable on the left side. So, remember I said for some reason, for whatever reason, I just like it over there. Some of you probably moved the 4x instead. Did anybody do that instead? Yeah. And then you just end up having to divide by a negative, which then switches the symbol, right? Am I right about that? Okay. So now we are going to graph this, but then we're also going to state, this is one of those kind of problems that we're going to state it in a sentence, what really is going on here. So if I graph it, I can see all of the possible things my number can be. Right? So the number In this case, it's not just a number. The number is any value. What does this say or show? Greater than -3. So it isn't just one number, there's a whole bunch of them. How about -3? Does it qualify? No. How about -4? No. There's a whole bunch of numbers, including -3 itself, that do not qualify to be the number, but we have a whole bunch of others that do. Any of those others should satisfy that statement. Okay. Any questions? Okay. Then the